Okay, so today we are going to discuss some NET past paper questions for the topic number systems. So let's get started. Okay, so the very first question says, the set of rational numbers between two real numbers is, okay. Now we need to think about two real numbers and then we'll talk about rational numbers, right? Let's say we take 0 and 1, okay? So 0 and 1, they are real numbers. Let's think about them on number line. Okay, so this is our number line. Let's say we have 0 here and 1 is somewhere here. Okay, now 0 and 1 are real numbers. And if I talk about rational numbers, so any number that can be written as a fraction or has a terminating decimal is basically a rational number, right? So if I talk about 0 and 1, I know that between 0 and 1, I am going to have 0.1, then I'll have 0.2, so on, okay? And now if I talk about 0.1 and 0.2, I am going to have so many decimal numbers, so many terminating decimal numbers between it. Let's say this is 0.1 and then this is 0.2. So I will have 0.1001, then I am going to have 0.1002 and so on till 0.2. This means that I am going to have infinite many numbers, infinite many terminating decimal numbers between any two real numbers. Now here initially I took 0 and 1 for my reference. I could have taken 0.1 and 0.2 because again 0.1 and 0.2 are also two real numbers, and between 0.1 and 0.2 I am going to have 0.101, 0.102, 0.103, so on and so forth. So this implies that I am going to have infinite many numbers between any two real numbers, right? So this is basically option C. Okay, we are done with the first question. All right, now we have the second question. Okay, so for the second question, multiplicative inverse of a non-zero element A is. Okay, now let's say A is the element. If I'm talking about the multiplicative inverse, it should be such that when I multiply A with it, I get my multiplicative identity, right? And what is multiplicative identity? It is 1. Multiplicative identity is 1 and additive identity is 0. So far we're talking about multiplication. I want such a number that when I multiply it with A, when I multiply it with my element, I get the multiplicative identity, right? So the multiplicative inverse of A would be A into 1 by A. That is going to give me 1, right? So this means that the multiplicative identity is 1 by A. So here C would be the option. Okay. Now let's talk about the third question. So the statement is the set. Now this is a set. This is our set. X belonging to real numbers. Now here our X is basically belonging to real numbers. Okay. Now this part is important. Okay. Just focus on that. Okay. And the condition is that x square plus 10 equals 0. All right. Now let's just write it down. X square plus 10 equals 0. All right. So basically they want us to define this set. They want us to tell the elements of the set, right? Okay. So we are going to do that by basically working on this equation. So if I take 10 to the other side, I am going to get minus 10 here. So x would be under root minus 10. This basically means it is under root minus 1 into under root 10. And under root minus 1 is iota, right? It is complex number. So iota under root 10 into iota. Now this is what I'm getting with a plus minus sign, definitely with a plus minus sign, with a plus minus sign. Okay, right. So this is what I'm getting for x. But the thing is, here we have been told that this set has x and all these x belong to real numbers. Now this is an like obviously it has the iota part, it is the imaginary part, but in general this is a complex number. So we do not have complex numbers in real numbers, right? So this means that this is null set because there is no x that is a real number such that it satisfies this equation. If we would have ended up getting x as 1, 2 or any random number, let's say even under root 10, then our set would have included that number. Here we are getting a solution for x, but this solution is basically a complex number, and here we are talking about real numbers only. So this cannot be a real number. This implies that this set would be null set because the condition was that x is belonging to real numbers, but plus minus under root 10 iota is a complex number. Okay, perfect. Let's talk about the fourth question now. All right. Okay. So the question is, additive identity on n is, all right. Now n is basically the set of natural numbers, right? It is the set of natural numbers and it begins with 1 and then we have 2, 3 and so on. So basically we do not have 0 here, and here they want us to tell the additive identity. So I just told you that the multiplicative identity is 1 and the additive identity is 0. So this means that A would be the answer? No. Although the additive identity is 0 and A should have been the answer, but if the set was of real numbers. Here we have the set of natural numbers. In natural numbers, we do not have any additive identity because it is starting off with 1. There's no 0 before 1. If a set has no 0, obviously it implies that it is not going to have the additive identity. So C is the answer, right? No identity. The set of natural numbers has no additive identity, right? Okay. Now let's just talk about the fifth question. Okay. So for the fifth question, we'll do it here. Additive inverse of 2 plus under root 3 is, okay, now they're talking about additive inverse, right? So additive inverse of any number is basically such that when I add it to that number, I get 0. I get the additive identity. So let's say if A is the element, the additive inverse of A would be minus A, because only then I'm going to get the additive identity, that is 0. Okay, so in this case my number is 2 plus under root 3 minus 2 minus under root 3 is going to give me 0, right? So this means that this number right here is basically our additive inverse. Okay, so you can also think about it like this, that you add your additive inverse, that is basically minus this, so it would at the end become this. Okay, again for this we can write it like this: 2 plus under root 3 plus the additive inverse, that is minus 2 minus under root 3. So since minus into plus is minus, so I just wrote the final step directly, right? So this means that this is our additive inverse. So C is the answer. Okay, this part is clear. Now let's talk about the sixth question. Okay, the multiplicative inverse of under root 7. Right, now they want us to find the multiplicative inverse of under root 7. Okay, so for this, we can just do it here. Multiplicative inverse of under root 7. Now think of 7 as a and think of another number such that when I multiply it with under root 7, I get the multiplicative identity, right? So under root 7 is the number. I need to multiply it with another number such that when I am multiplying it, I get the multiplicative identity. So that would be 1 over under root 7, right? But we did not have 1 over under root 7 in our options, okay? We had under root 7 by 7 in our option. So now if you simply use your calculator, obviously you would not be allowed to use your calculator in NET, but if you do it right now, you will get to know that 1 over under root 7 and under root 7 by 7, they are same. Since they are same, it implies that this would have been the answer, okay? All right. All right, so now if we have a look at it, as I said, this is the answer because this is basically 1 over under root 7. If you check it on calculator, 1 over under root 7 is this. Obviously in NET, as I said, you would not be allowed to use your calculator. So you should know such things, okay? So this is the answer because if I multiply it with under root 7, I am going to get 1. That is the multiplicative identity. Okay. All right, now we have this part. Right, so the question is to find, I'll write it here. It's 1 by 2 plus iota under root 3 by 2 to the 6, right? We need to find this. But obviously, first thing is that you would not be using your calculator. The second thing is that obviously you'll be doing it by yourself, right? Manually. So if you're doing something manually, like so far, we just know how to open up the square, right? So obviously we need to break it down into something which is possible for us. That would be 1 by 2 plus iota under root 3 by 2 to the square multiplied by 1 by 2 plus iota under root 3 by 2 square. Again the same thing. Why am I doing this? I'm doing this because I know when bases are same, powers are added. Okay, now since this is this, I can simply break it down into 2 into 2 into 2 because like now I have the same powers. When bases are same, I can add the powers. So this is basically going to give me 1 by 2 plus iota under root 3 by 2 to the 6, right? I've broken down into 3 easy parts just so I'm able to simplify this easily. Okay, this is perfect. All right, now let's just do it. Okay. All right, so if I break this down, just have to do for this part because other two parts are same. I'm going to get 1 by 4, 1 by 2 into 1 by 2 plus iota under root 3 by 4 right? Then I'm going to get plus iota under root 3 by 4, and then I'm going to get plus iota square under root 3 by 4, right? So this is basically going to give me 1 by 4 iota square is minus 3 by 4 plus iota under root 3 by 2. So I've added up these two. Okay, and now this is going to give me 1 by 4 is 0.25 and 3 by 4 is 0.75. So I'm going to get minus 1 by 2 plus iota under root 3 into 2. Okay. Now this is basically for this, right? For this square, this first bracket, I got this as my answer. Now obviously I have to multiply it 3 times because I have this again here and again here. Okay. Now I'm going to rub some of the things and just write down the answer. Okay, so after my calculation, I got that 1 by 2 plus iota under root 3 by 2 square is basically minus 1 by 2 plus iota under root 3 by 2, right? Okay, now I have to multiply it 3 times because I have it 1, 2, 3 times. All right. Now let's just multiply it 3 times. Okay, so I'm going to write obviously initially I'm just going to multiply it twice just to keep things simple for myself. All right, let's just multiply it. So minus 1 by 2 into minus 1 by 2 is going to give me 1 by 4. Then I'm going to get minus iota under root 3 by 4, again minus iota under root 3 by 4, and then I'm going to get plus iota square 3 by 4. So this is going to give me 1 by 4 minus 3 by 4 minus iota under root 3 by 2. So this is basically minus 1 by 2 minus iota under root 3 by 2. Okay, perfect. So I will write it down directly. Okay. So I got this is equal to minus 1 by 2 minus iota under root 3 by 2. Okay. Now the question was this. This was the question. I simply have to simplify it. It has the power 6. It has the power 6. I've broken down the 6 into 2, 2, and here I also had 2 in the power. And this 1 by 2 plus iota, excuse me, under root 3 by 2 to the square is this right here. Okay. So I'm done with this part. Now I simply have to multiply it 3 times. So I've multiplied it with itself again like twice. So I'm getting all right. So basically think of it like this. All right. Now I got this for this, and for these two, I got this, right? So the yellow one is for the first bracket and the purple one is for the for 2 and for 3. Okay. Now let's just look at the type. So this is minus 1 by 2 plus iota under root 3 by 2, and this is minus 1 by 2 minus iota under root 3 by 2. So isn't it the A plus B and into a minus b form, for which we get a square minus b square. So my a is minus 1 by 2. I simply need to square it. Then I will write down the minus sign, and then I need b. My b is iota under root 3 by 2. So I have to square that as well, right? Okay. So this is going to give me 1 by 4, right? Then I will have this minus sign here because I'm going to write a square minus b square. This is basically iota square under root by 2. The square is going to cancel this 3 and I will get 4 here. And this is going to give me 1 by 4 minus into iota square would be plus 3 by 4. That is basically 1. So clearly C is the answer. So here I'm going to repeat it. We had the power of 6. We cannot do it directly. So we just have to split it into what we can do directly. That is, I just kept the base same and I multiplied it 3 times with 2 as my power, because I know when bases are same, powers would be added. So this left side is equal to the right side, right? And I know I can solve 1, 1, 2, and 3 are same. If I can solve 1 is the yellow part, and I have just multiplied this yellow part 2 times because 2 and 3, this 2 and this 3, they are same, and 1 is also same. So I got the yellow part for 1. I multiplied it twice just so I can get the answer of 2 into 3, right? And this is the answer of 2 into 3. And once I'm done with every multiplication and all the complicated part, I noticed that this is basically the a plus b and a minus b form. So clearly a plus b into a minus b is a square minus b square. That and ended up as this, and finally I got 1 as the answer. So 1 is my answer. Okay. Now let's talk about the 8th question. If the square of a number x is I, then x is, okay. Now we need to talk about x. Okay. Let's just write it down. If square of a number x is I, right? This is what the statement says, then x is, okay. So the English, if the square of a number x is iota, is basically written as this in mathematics. Now if I solve it directly, I am going to get x equals plus minus under root iota. Now let's just see if we have this in options or not. Okay, so clearly A, B, C, D, all the options have like different complex numbers. I do not have what I got as my answer. Okay, so this means here we need to do something different. Here we are not supposed to do things this way. Here we are not supposed to solve x on our own, but do things in a different way. Here I have to simply choose all the options and I have to insert it in the x, like in this equation. I had x squared equals I. I simply have to use a, b, c, d as x, and then I will see if my left hand side is equal to the right hand side or not. Okay, so this is square. Okay, perfect. All right, so this is the question. Right, so I can write it as, okay, now I need to use a option is 1 plus iota under root 2. Okay, I need to use this a option as x, so this would be 1 plus iota divided by under root 2, and I have square here. I have the square here. This is going to give me 1 plus iota into 1 plus iota divided by 2, because under root 2 square is basically 2. Okay. This is going to give me 1 into 1 is 1 plus iota plus 1 into 1 is 1, 1 plus iota is iota, iota into 1 is iota, and then iota into iota is iota square divided by 2. Okay. Now again, I'm still at the left hand side. Okay. I have used option A as x, and now I'm just simplifying it. So I'm going to get 1 plus 2 iota minus 1 divided by 2. So this is going to give me iota. So 8 is basically iota, right? So this I'm getting iota, which is basically my right hand side. So if I use A as the answer, my left hand side is equal to right hand side. So this implies that A is the answer, right? Okay. Now let's just talk about the ninth question. If z equals x plus iota y, then z square plus z mod square. Okay, so let's talk about z square. This is going to be x plus iota y square equals z mod whole square. All right. So z mod would be x square plus y square. And when I'll do whole square, this would be cancelled. So this is going to be x square plus iota square y square plus 2x y iota equals x square plus y square. Now clearly these two cannot be equal. They can only be equal if y is 0, because this is basically going to give me x square minus y square plus 2x y iota. Now here I have plus y square, so clearly this is the error, and I do not have any iota part. So this means that y equals 0 would imply that this becomes a real number, and this only holds for real numbers and not for complex numbers, right? So this would be the answer, because clearly this is only possible when y is 0. Why? Because of this I'm getting minus y square and I'm getting 2x y iota. So if y is 0, I'll only get x square equals x square, right? So B is the answer. Okay. And now we have the last question. Last question says argument of z1 by z2 is, all right. Okay, so basically this is a property where whenever we have this, whenever we have argument of, let's say I have two complex numbers, I have argument of, let's say, z1 by z2. Now this property says that this is basically equal to argument of z1 minus argument of z2. So basically argument of the complex number in numerator minus argument of the complex number in the denominator, right? That is z2. Okay, so this means that this would be the answer. Okay.